Hello students, welcome back to our channel Maths Infinity. Today we will solve a problem of JEE advanced level and multiple options are correct. The problem is given that a function f is from R to R is of the form x plus log of 1 plus x square. Then which of the following options are true? If it's injective and x tends to minus infinity, if x equal to plus infinity, and option C, there is point y is equal to fix where tangent is not parallel to the chord, and option D, if is bijective. Okay, so we will solve this problem by sketching the graph of fx. Okay, to draw the graph of fx, at first we have to know what is the graph of log x. Okay, so we start with the graph of log x. Okay, at x equal to 1, log 1 is 0, and after that it's strictly increasing, and between 0 to minus 0 to 1 log x is negative, and x tends to 0, log x tends to minus infinity. So this graph becomes asymptotic. Uh, so now we are going to draw the graph of x plus log 1 plus x square. First we look the either the function increasing or decreasing. So the easiest trick to check this, we will just take a derivative of this function. So f dash x is 1 by 2x by 1 plus x square. So this is 1 plus x whole square by 1 plus x square. Since the function is defined from R to R, for any real number, f dash x is strictly greater or equals to 0. Only at x equal to minus 1, f dash x equal to 0. This is always positive. So the given function, that is x plus log of 1 plus x square, is always increasing function. And one more thing, students, look, for all real x, x square always greater or equals to 0. So 1 plus x square will be always greater or equals to 1. And so log of 1 plus x square will be always greater or equals to 0. So to understand the nature of this graph, we have already know that this part of this graph, that is log of 1 plus x square, is always positive, and at x equal to 0 this will become log 1, that is 0. So to draw its graph, just now we going to draw the graph only for the positive portion, that is when x greater than 0, then this x will be also positive for x greater than greater equals to 0, and at x equal to 0 f of 0 becomes 0 plus log 1, that is 0. And after that, from this portion we can say that this graph will be look like this. Okay, this will be strictly increasing. Now students, when x, for the rest of negative part, that is for this part, look, x will be always negative. So this is my fx, x plus log 1 plus x square. This part will be negative as x is negative, but 1 plus x square is always positive. Okay, we have already derived it, that for all x in R, this is the portion for all x in R, x square is strictly greater than 0, so 1 plus x square always greater equals to 1. As a result, log of 1 plus x square always greater equals to 0. So what will be the resulting sum of these portion? Okay, for x less than 0, that is for when x is negative, when x is negative, what will be the resulting sum of these functions? Okay, what will be the sum of this resulting function? To uh, determine the sum, either positive or negative, we have to uh, construct another function, and we can then sort out these things. Okay, because at this stage we don't know whether the value of x or value of log of 1 plus x square is larger, so we can't conclude here. Okay, to see the uh, who will be absolute value of which x or log of 1 plus x square will be larger, let's construct a function psi x minus log 1 plus x square. Now, as you can see that side x equal to 1 minus 2x by 1 plus x square, that is 1 minus x whole square by 1 plus x square, which is always greater equals to 0. So we can say that psi x is an increasing function. So just use the definition of an increasing function. As x greater than 0, it will imply psi x greater than psi 0. So x minus log 1 plus x square will be strictly greater than 0, and as a result we derive that x is greater than log of 1 plus x square. This is the main trick of this result. So since x is negative, just look at this function fx. Since x is negative and x is greater than log of 1 plus x square, so we can now say that the resulting function, the value of this function will be negative, as x is negative. So the graph for these portion will be like this. Okay, now we are going to draw this clearly, graph. This is for the positive portion, and here this it will goes to minus infinity, and its slope will be just lighter than the positive portion. Okay, and just look at this problem. Just I'm going to paste the problem once again here. This is the problem. So just look at this thing. Option A, f is injective. Now students, we will learn another thing, the geometrical interpretation of a function when it is injective. Okay, just remember the definition of injective. If function a to b is injective, that's 1 1. When for two different value in the for domain, for two different points, we will have distinct value of this function. Okay, now when the function becomes injective or not injective, Look, suppose this is a function, and if we draw a line parallel to this x-axis, that is, suppose y is equal to k, a line parallel to the x-axis, and it's cut fx at two distinct points. Suppose this is x1 and this is x2, and here uh, at these two distinct points fx1 and fx2, at this since this parallel line cut at two points, we can say that fx1 is equal to fx2 is equal to k. So in that case f is not injective. Okay, so clearly we can say that when a function is not either increasing or either strictly increasing or either strictly decreasing, the function is not injective, because we can see that the function is increasing here, and from there to here function is decreases. So the any line parallel to the x-axis can cut at two distinct uh, points. Okay, so in that case the function may fail to be injective. So the criteria to a function to become injective is that it will be either strictly increasing or strictly decreasing. Since already we have derived that this function fx, that is x plus log 1 plus x square, is strictly increasing, so we can draw any line parallel to x-axis. It will cut the graph exactly at one point. Okay, anywhere you can draw any line, just it will cut the graph exactly at one point. So option A is true, that is the function is injective. Now clearly from this graph already you have derived that as x greater equals to 0, the function goes to plus infinity, and x less equals to less than 0, it goes to minus infinity. So option B is also true. Now for the option C, it is told that, so sorry, option B is given x tends to minus infinity if x equal to plus infinity. So this is wrong, this is wrong. Okay, just I have missed the sign. I thought this is plus minus infinity. Sorry students. And option C is given, there is a point on the graph y is equal to fx where the tangent is not parallel to any chord. Okay, just go back to the problem. Just what is f dash x? F dash x equals 1 plus x whole square by 1 plus x square. Just here, as you can see that f dash minus 1, if we put x equal to minus 1, then so the numerator become 0. So as a result, f dash minus x equal to minus 1, f dash minus 1 is 0. So at x equal to minus 1, the tangent will be parallel to x-axis. At x equal to minus 1, the tangent will be parallel to the x-axis. And this, since the function is strictly increasing, it will be not parallel to any chord. So option C is also true, students. Okay, I think you understand this. At x equal to minus 1, suppose this is x equal to minus 1, the tangent will be parallel to x-axis. Okay, the tangent is parallel to the x-axis, and since the graph is strictly increasing, it will be not parallel to any chord. And finally, since the function is already, we have derived that it is 1 1, so one condition for bijective already satisfied, and condition 2 can be easily see that the condition 2 also holds as the function, the range of f is minus infinity to plus infinity, that is R. So f is surjective also. So or that is onto. So combining these two points, we can say that f is bijective also. So the correct options are A, C, D. So students, I think you understand the problem, and the main important part of this problem is that the sketching of this graph. If you have any doubts, you can comment. Okay, thank you.